Cascadia. My name is Amber Hoak, and I'm really excited to be talking with you today. I'm a software engineer at Microsoft Research, but I spend most of my time doing data visualization. So today I wanted to talk to you about SVG, Canvas, and WebGL, because as an engineer, you're in a beautiful position to use these technologies to tell complex and compelling stories with data. So maybe you want to persuade your boss to give you a raise, or maybe you want to convince somebody that LeBron James is actually the greatest basketball player of all time. Or maybe you're trying to advocate for some kind of social change movement. Well, here's a trick to getting people to listen. Visual communication. There are numerous psychological studies that have shown that people are more likely to remember pictures and images than words. And there's even a name for this phenomenon. It's called the picture superiority effect. So why do we love visuals so much? With visuals, we can see into worlds that don't even exist, like Middle Earth or the Outer Rim. And we can even evoke emotions like happiness or sadness. And at its core, data visualization is visual communication. It can inform, influence, and persuade people. As an example, maybe you've seen this. This is the flatten the curve chart. This was a highly effective argument on the effectiveness of protective measures during COVID. And through data applications, we can communicate both simple and complex ideas. Data visuals can be like a telescope. It can make things that are big, like a satellite constellation, into something that's small. And it also can be like a microscope, making things that are small, like a protein or a neuron, into something that's big. And the best part is, with modern browser technology, we're no longer limited to just bar charts or scatter plots. We can now render hundreds of thousands of points, meaning that we can visualize things like a graph of Wikipedia articles. With this, the biggest barriers to these technologies is the complexity of learning these technologies. So I'm going to back up a little bit more and talk about my work. I build data visualizations to give insight into large data sets, which is just kind of a fancy way of saying that I build charts and graphs. I work with a team of really smart data scientists that build out these algorithms, and I develop interfaces to display the outputs of those results. Prior to starting this job, I didn't really have any experience with data visualization. My journey kind of looked like this. I started with these out-of-the-box solutions, the plug in data and out pops a chart and life is good. And I loved it, but that wasn't going to work for my first assignment. I needed to build a scatterplot histogram hybrid chart thing. So I needed to go into this custom solution zone. And with this, I need something low level. I needed to control things like animation and axes and colors. So I needed to learn how to use D3. I was already using React, and so I just needed to figure out, how do I use these two technologies together? I lived in this SVG world for a long time, until the day my data got too big, my application slowed down, and everything looked like rush hour and I-5. So I transitioned to use a more performant technology, WebGL, and I found that a little intimidating. So I wanted to create this talk to give you a friendly approach on how you can go from SVG to WebGL. In addition, I want to talk about the good and bad aspects of these different technologies, look at a couple of fun use cases. We'll go over a little bit of code, and then we'll wrap everything up talking about a hybrid solution architecture. So I'm going to put this link into the chat, but this is a link for all the resources for this talk, as well as the code. And I'm also going to drop in any applicable links as we go through the talk here. So let's get started. So let's start off talking about my favorite, scalable vector graphics, or SVG. I love SVG. It's like the gateway drug into data visualization. And the reason why is because it lives in the DOM. So we can use it as an HTML element, and we can also manipulate it in JavaScript. So I made these two categories called oh hey and no way, as like a pros and cons, but in a more fun way. So one of the oh hey factors of SVG is that it does live in the DOM, so we can easily inspect SVG. SVG acts like a scene graph where we can control groups of elements. So if you've never seen SVG before, here's an example. It kind of looks like XML. We have these concepts of graphical primitives, and here we're seeing a circle and a rect. And with that, we can attach properties like height and width and X and Y positions. So we can also use the CSS that we know and love. We can hook into eventing, like on mouse over and on click. That stuff just works. And the name doesn't lie, it's built on vectors, which means that it's going to have the same resolution on all devices. This can't be said for a pixel-based approach like Canvas or WebGL. And it also has really good browser compatibility. Some of the things that are in the no way category is it takes a little bit longer for reflow and repaint. So reflow is layout, like how things are positioned, sizes, and that kind of thing. And repaint is re-rendering that onto the DOM. And in my personal opinion, I think animations with D3 and React can be a little bit tricky. But overall, we love SVG because it just works. So I made this little benchmarking application to highlight some of the differences between these different renderers. So let's check it out. So this is the benchmarking application that I was talking about, and it looks like a little party. It's just a bunch of circles going back and forth. But what this application is allowing us to do is to calculate the frames per second on each tween. In other words, we're going to be able to compare how long it takes for the circles to go back and forth. And the idea is that we're going to adjust the number of circles that we're putting onto the screen here with this slider. And then we're also being able to change our renderer between SVG, Canvas, and WebGL. So right now what we're using is SVG at 500 circle count, and we should be seeing somewhere between 50 to 60 frames per second. The cool part about SVG is we can visually inspect it. So let's go into the inspector tool. We have this SVG element here. And if we go inside of the SVG element, we have these circles, and we're getting really granular data from the circles. We're getting the radius, the fill, the X and Y position, and this is a great advantage to us. Imagine that your circle was out of bounds of your SVG and you couldn't see it. We could visually see that in the inspector. So let's bump it up a little bit to 1500. So we're getting, we should be getting like 20 to 30 frames per second, which looks like we are. So not great, but the rule of thumb is to try to keep your frame rate above 24 frames per second. So for fun, let's see what happens when we go to 10,000 circle count. So very slow and chunky. We're in the single digits for frame rates. And SVG has a really difficult time animating this many elements. But we can still create some really cool things with SVG. Let's check out a couple of examples. This is an article called 10 Things Everyone Hates About You. And it's done by The Pudding. The Pudding does data-driven journalism on social issues. And what this article is about is it analyzes data from a dating app called Hater. Hater basically matches you with someone who hates the same stuff as you, from anything from beards to Beyonce. So what I wanted to show you was this small multiples of a line chart here. This is showing things that we love and hate and how they change as we get older. But these are all built with SVGs. So because they're built with SVGs, we can go and inspect it, and we can look at it in these different devices. So if we change to, let's say, a Pixel 2, boom, has still really crisp resolution. There are several ways that we can build custom charts like these, and one of it's with D3. So let's step through how to build a SVG using D3 in React. So if using React is your jam, let's look at how we can use D3 and React together. I think it's important to note that there are 5 strengths of D3. That is layout, brushing and zooming, animation, axis, and scales. And of these, brushing and zooming, animation, and axis actually need some kind of DOM control. So let's look at how we can use this in a render statement for React. So say we have an outer element somewhere in our tree that's going to be calculating our height and width for our SVG here. We're going to have a couple of G elements. A G element is just a container that's used to group other SVG elements. And with that, we're going to attach a ref to these G elements. We'll use that ref within a React hook, and that will allow us to use the D3 axis generator function. This will attach our X and Y axis to our SVG. Similarly, we're going to have a G element, and this is going to draw our data onto the SVG. We'll be using this within a React hook and using a .data.join pattern. So let's look at an example of that. We're going to use a use layout effect hook, and we're doing that .data.join pattern. And at a high level, what .data is doing is evaluating our current data based on our previous data. And .join is handling how elements are treated as they enter the scene, are updated, and exit the scene. So depending on the amount of animation, we saw that our limit for SVG was around somewhere between 1,000 to 2,000 graphics. But SVG has a lot going for it. It's easy to use, so it's worth it for us to try to improve SVG if we can. So a couple of ways that we can do that is look at how we're using D3 in React. Using D3 as a visualization utility and use React to handle the rendering. We can look at windowing our data and not rendering things that aren't visible. And the inspector is always our friend. We can use it to find our pain points. So if trying to improve SVG still isn't working for us, we can transition to something more performant like Canvas or WebGL. So Canvas is the HTML5 DOM element type and creates a bitmap image. It has two different drawing modes, 2D or WebGL. Since here when I'm referencing Canvas, I'm actually talking about the 2D graphics API. It's the predecessor of WebGL. It tends to be good for like light applications that just need a little bit of a boost. So for the 2D graphics API, some of the oh hey factors of it is it's a little simpler than WebGL. And it supports legacy browsers. It's existed since 2004. And a couple of things in the no way category is it's a black box debugging. Unlike SVG, we're not going to get any of that granular information. We're just going to get a Canvas tag. And then it runs on the CPU, not on the GPU, like we would see with WebGL. So let's talk about WebGL. WebGL is the bare bones basics of computer graphics. It's made up of a parallelized array of triangles that we just texture. And with WebGL, we can use shaders. Shaders are written in GLSL. GLSL is based on C. It's like really low level and honestly kind of complicated. It takes like 200 lines of code just to render a square. But we love WebGL because it's super fast. So it's super fast because it runs on the GPU. And then it looks cool because now we can render even more points. We can build things in 3D. So let's look at an example of SVG versus WebGL. This is a performance report on just one of those tweens. And we can see here is almost 1,000 millisecond increase in the rendering and painting for the SVG version versus the WebGL. So this means that we can render more points onto our DOM than we could with SVG. And then it has pretty decent desktop browser support, but some of the things that are in the no way category is it has that black box debugging like we saw with the 2D graphics API. It takes a little bit longer to develop with WebGL, and mobile compatibility is kind of spotty. But I would say that the worst part of all is that it has a lot of math. But luckily for us, there's a couple of options. There's Pixi.js and Three.js. So Pixi marketed itself as a 2D gaming engine, and Three.js is kind of the equivalent in the 3D space. So later we're going to look at how we can build a data visualization with Pixi, but for now, let's look at Pixi in action. We're going to check out this bunny mark application and also look at that benchmarking application again. So welcome back to the circle party. So if you notice here, instead of using the SVG renderer, we're using the Canvas renderer. And we're getting about the same frame rate for 500 circle sprites. So what we're looking at is 500 Pixi sprites textured as circles, tweening back and forth on our Canvas renderer. And we're getting between 50 to 60 frames per second for our 500 sprites, which is really good. So if we open up the inspector here, what we're seeing is this Canvas tag, and we're not actually getting any of those sprite elements nested underneath like we saw with SVG. So let's bump our circle sprites up to 1500 again. And look, we're not getting the drastic decrease in frames per second like we did with SVG. So that's good. Let's go somewhere in the middle of our counter. So we're getting a little bit less frames per second here. Now let's bump it to the limit, 10,000. Let's see what happens. So really not doing that much better than SVG at this point. But maybe we should check, see how WebGL would do. So let's click on WebGL and wow, it's incredible. We're getting almost 60 frames per second at 10,000 circle sprites. So that's really awesome. But you don't have to take my word for it. We can verify our findings with the Pixi bunny mark. The Pixi bunny mark is a tool built by Pixi to kind of just say, how fast can I run these sprites on my current device? So we can specify an amount of bunny sprites that we want to render. Here we'll specify 10,000. And for the render options, if we click Force Canvas and Legacy, that will force our renderer to use Canvas 2D API. So let's press Go. And right now we're getting 6, 9, 8 frames per second. So pretty comparable. So let's exit out of that. And now let's try the same thing, 10,000 bunnies. But if we don't press any of these options here, it's going to default to WebGL if it's available to us. So let's press Go. So now we see we're getting almost 60 frames per second like we saw before. So maybe you're wondering, why should I even use the 2D graphics API for Canvas? Why not go straight to WebGL? Well, let's look at this example. Shirley Wu is a freelance data visualization designer out of San Fran, and she made this piece called 4 Years of Vacation and 20,000 Colors, and it's kind of just a pet project. So what she did was she extracted colors from her travel photos and plotted them here. And around, she plotted in this SVG kind of a narrative of her experience. So the interesting thing is how she made this. So the circle elements themselves are made with SVG, the outer circle, but these colorful circles in the middle are actually made with the Canvas 2D Graphics API. And we can see when we reload this page that these Canvas elements are actually animating into a D3 force layout. And due to the amount of circles animating, this would have been really difficult to do with SVG. Now let's look at an example of WebGL. This is an interactive visual of 150 years of academic papers published by the journal Nature. Each circle represents a paper, and 2 circles are linked if there's a citation to another paper. It's color-coded by research domain, and it shows how academic work is intertwined and builds off of one another. Another example of WebGL is Sandance. So Sandance is a project from Microsoft Research, and what it is basically right now we're looking at 25,000 data points. Each of these tiles is a data point. And the interesting thing is that we can transition between layouts. Because this is all built with WebGL, it's really responsive and super smooth between these layouts. So now let's look at how we can use Pixi to create data visualizations with WebGL. We are going to manage our data with Pixi in 3 steps. First, we're going to create a Pixi class with a constructor. In the constructor, we are going to set up a sprite container, which will act like a stage. And we're going to set up a renderer, and this renderer is going to paint our stage onto a canvas. Next, we're going to create an enter data function, which will handle the initial data entering our scene. So let's say that this is our data, and we want to plot based on the dog's age. So for each of these data items, we are going to have a unique ID. We will create a sprite for each of these IDs and then put each sprite in a sprite map. So that way we don't need to destroy or recreate sprites. For each of these sprites, we are going to attach properties like position and texture. After that, we will attach our sprites to the stage container and then call our renderer to paint it to canvas. Now let's say if we want to update our data and we want to do that with animation, we can do that in a request animation frame loop. This is also called a game loop. And how it works is we specify a duration for the tween and call request animation frame. We are going to iterate through our data and look at the corresponding sprite from our sprite map. Then from there, we're going to update our sprite properties. In order to get that animation effect, we're going to calculate our sprite's position value somewhere between our current position and our end goal position based on how far along we are in the tween. Then we're going to call our renderer again to paint these updates. We will continue this loop for the total duration of our tween, updating positions throughout the loop. So sometimes the solution that we need is not just one technology, but multiple technologies. So let's look at how we can layer these technologies. Here's an example of how we can layer SVG, WebGL, and HTML. This example shows nearly 60,000 dog posts from the Pet Finder API on a specific day. Each circle represents a post. The x-axis is the dog's age, and the y-axis here is coat type, but we can change that to a different filter. Due to the size of the data, this would be really difficult to do with SVG, so I moved all the data circles to WebGL using a Pixi renderer. However, below the Pixi element is an SVG that handles the axes. A HTML tooltip above the canvas is updated on mouse over events. So WebGL gives us the benefits of being able to smoothly transition between these different filters, and this type of approach allows us to offload things that need the extra performance boost. So to wrap everything up, what's the best technology? I think like everything else in life, it depends. SVG, Canvas, and WebGL all have its place, and it's really up to you and your data needs. I hope you can find this as a launching point to tell meaningful stories with data. Thank you so much for having me. This has been such an incredible experience. And if you have any questions or comments, please reach out to me on Twitter. Thank you so much.
Wow! Oh my gosh, thank you so much for that talk, Amber.
Hi, Cassidy. Thanks. Yeah, I was super excited to do it.
Yeah, oh my gosh, I loved how practical it was, and your live sending of the links in the chat was so helpful too. I think I've bookmarked at least half of them, and your demos were so useful. I can't gush enough.
Oh, thank you. I appreciate it.
So we do have some questions from the audience. So there are some people saying my mind is too blown to ask questions. This is amazing. But I think the number one question people have is, do you have any advice on how to make these data visualizations accessible?
Oh yeah, absolutely. I think this is a really big topic, and I actually didn't talk that much about it because it is such like it could be a talk on its own.
Really
I think that there's a couple of different strategies that we can use to make these data visuals accessible. One thing is looking at colors and how we're using colors in our data visuals, using colors to differentiate categories, using keyboard navigation to like tab through visuals. And sometimes this might not work for complex visuals. So we might need to do something like replace that with a table or a summarization of data to make it easier for screen readers. And enabling and disabling animation is another way to kind of go in making things a little bit more accessible. I put a few other tips on that big long README on that SVG page, and I'm willing to talk about that later too, because it's just such a broad topic.
It really is. And even just that, colors are something that people forget so often, and having the right contrast and differentiation for that is so huge.
Absolutely.
So are there any libraries or plugins or resources that help bring React or Vue or Angular together for this? Because I noticed you were using use layout effect and some other React functions, but I'm sure there's others you might not have mentioned.
Yeah, so I am primarily React, so I cannot speak for the other frameworks. But for React, I know that they do have React 3 Fiber, and that's like a great way to kind of abstract some of those low-level WebGL mathy stuff. And I'm sure there's a lot of other resources. And if somebody else has some suggestions, like feel free to put that in the chat. I did want to like add a little extra something that I didn't talk about in the actual talk. That's really exciting. I'm super excited about WebGPU API. It's the next generation of 3D graphics. Yeah, it's the new hotness, and is offering better performance and more predictable performance than WebGL. So they announced that at the Google I/O in 2019, and it's still in development. But I think if you're like really interested on like the cutting edge of 3D graphics, that might be something to check out.
Ooh, I will totally check that one out. Do you know if it is a similar language to WebGL? I know it's a new technology, but is it a similar language, or are they making a whole new API for it as well?
I think it's going to be a new API. It's going to be the successor of WebGL, the next version of WebGL, if you will.
Neat. Ooh, I'm definitely going to look at that. We have so many questions pouring in, so I'm going to try to be aware of time. How do you determine the best design for data visualizations? Do you kind of just have an eye for it or go for it, or do you have a rule of thumb that you follow?
I think that this is like the design portion is really up to what your data needs are and what you're trying to convey. And I think that is really central to how you build your data visualization, and always try to keep it simple. I usually try to start with SVG because out of the gate, that's the easiest to work with, and then try to move stuff that's not performing well to WebGL because that is a little bit more overhead and might take you a little bit longer to do.
Yeah, that makes a lot of sense. Well, thank you so much again for your talk. I'm completely geeking out about it, and I know I'm not alone there. So thank you again for being here.
Thank you, Cassidy, and thank you, Cascadia. I look forward to seeing everybody at karaoke.
Yeah. It should be fun. Okay, thanks, Amber. And up next, we have I'm sorry, I totally mispronounced that. Rahat coming to come speak. Let's go.